everybody. So we started talking about sine, cosine, and tangent ratios. And today we're going to keep practicing and then we're going to actually start solving. So I want you to go ahead and I want you to write the sine ratio, cosine ratio, and tangent ratio for number 1 and number 3 on this piece of paper. Obviously we can't do number 2 because I have no reference angle. So I'm just going to put an X through number 2. So I want you to go ahead and pause this video, write the sine, cosine, tangent ratio of each, and then unpause to check your answers. So if my reference for angle is theta, sine of theta is 4 over 5. Cosine of theta is 3 over 5. And tangent of theta is 4 over 3. On number 3, sine of theta is 28 over 53. Cosine of theta is 45 over 53. And tangent of theta is 28 over 45. Okay? So if we take a look at this next problem, it says, given the following triangle, find the sine, cosine, tangent ratio of angle A. So, okay, I'm going to highlight angle A as my reference angle, and I'm going to label O, A, and H. Okay? What do you notice that's wrong about this problem? I don't have a value for H, so in order to find sine, cosine, and tangent ratio, I need to find all 3 sides of my triangle first. So if I have 2 sides of my triangle, how am I going to find the third side of my triangle? Well, I'm going to do the Pythagorean theorem. So 6 squared plus 8 squared equals x squared. Be very careful that you're remembering that C is always the hypotenuse. So I have 36 plus 64 equals 100. Oops, well, yes, that does equal 100, I agree, but I should write this correctly and say equals x squared. So now I have 100 equals x squared, square root, x equals 10. Okay, so now that I have all 3 of my sides, I'm going to go ahead and write my sine ratio, my cosine ratio, and my tangent ratio. So sine is 4 over 5. Cosine is 3 over 5. And tangent is 4 over 3. Okay. So now go ahead and pause this video and try number 5 on your own. Keep in mind that if this value here, when you take the square root to find that third side, if this is not a perfect square, you have to leave it in simplest radical form. Okay? So go ahead, pause the video, try number 5 on your own, and then unpause the video, and you can check your answer. So here's angle A. So I have to find this side first. So notice C4 is C, so I'm going to do 2 squared plus x squared equals 4 squared. If I can write. And now I have 4 plus x squared equals 16. And x squared equals 12. Square root, square root. Notice 12 is not a perfect square, so I have to simplify it. Square root of 4 is 2. Square root of 3 I can't do, so 2 rad 3. So now I'm going to come over here and I'm going to write sine of A, cosine of A, and tangent of A. I just noticed on number 4, my theta symbols, those probably should have been angle A because that was my reference angle, just kind of as an FYI. Okay? So sine 2 square root of 3 over 4, which I can simplify to square root of 3 over 2. Cosine is 2 over 4, which I can simplify to 1/2. And tangent is 2 square root of 3 over 2, which I can simplify to just the square root of 3. So if you take a look and you notice 6, it's the same type of problem, but what would be a helpful hint? Given triangle XYZ, if sine of x is 3 over 8, what's cosine of x? Should be cosine of x. So my advice to you is I would draw a picture. So I'm going to draw a right triangle. since x is my reference angle, it can't be the 90-degree angle, so x, y, z. So if x is my reference angle, I'm going to go ahead and highlight. Sine is opposite over hypotenuse, so 3/8. So same thing, I got to find this value down here first. So I'm going to do x squared plus 3 squared equals 8 squared. X squared plus 9 equals 64. X squared equals 55. Square root. 55 is as simplified as it can be, so this is square root of 55. So I want the cosine ratio of x. So cosine of x is the square root of 55 over 8. So go ahead and pause this video and try number 7 on your own. So APO, tangent is opposite over adjacent. So I have 2 squared plus 7 squared equals x squared. 4 plus 49 equals x squared. I have 53 equals x squared, square root. So sine of A is 2 over the square root of 53. If I leave my answer like this, I'm losing points because I have to rationalize the denominator. So sine of A equals 2 square root of 53 over 53. Okay. A great way to remember my trig ratios. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. A great way to remember this is what's called SOHCAHTOA. SOHCAHTOA. Okay. The S in SOHCAHTOA stands for sine, which means I use the opposite value and the hypotenuse value. The C in SOHCAHTOA stands for cosine, where I use the the adjacent value and the hypotenuse. And the T in SOHCAHTOA stands for tangent, which tells me I use the opposite value and the adjacent value. Okay. Another way you could write this to remember it is like this. SOHCAHTOA. It is spelled exactly as it sounds. SOHCAHTOA. Okay. However you want to use it, you don't want to use it, that's excellent. It's up to you. Just a friendly little tip. Okay. So recently we have been talking about all the trig ratios. I give you a triangle, I say find sine, cosine, and tangent ratio. Okay. But now I don't want to do that. Now I only want to create the ratio based on my given information. I don't want to do more work than I have to. Okay. So if we look at number 1, I'm going to highlight my reference angle, which is right there, and I'm going to label O, A, and H. Now notice in this triangle, I only have a value for O and a value for H. So instead of doing the Pythagorean theorem and taking all that time to find A, I'm going to use only one trig ratio in this problem. And the trig ratio that uses O and H is sine. So I would use the sine ratio in this problem. So if I wanted to set up an equation, it would say sine of theta equals opposite over hypotenuse. And this is what my equation would look like. Okay? Just like if I were to tell you 2 angles are supplementary, the equation you would make is that the 2 angles add them up to equal 180 degrees. Okay? So if we look at the next one, here's my reference angle. I'm going to label O, A, and H. The only values I have something for are A and H. What trig function uses A and H? Well, that's cosine, so I don't want to write with the highlighter. So I would use the cosine ratio in this specific problem. So if I wanted to create my equation, I would say cos of my reference angle equals 14 over 17. And this would be the equation that I would set up. Okay. we look at one more together, my reference angle, label O, A, H. The numbers I have values for are O and H. So what trig function uses O and H? Well, that's sine. So I would use the sine ratio here. So to set up my equation, it would say sine of my reference angle theta equals opposite 17 over hypotenuse 34. 17 over 34 can reduce to 1/2. So go ahead and pause this video and try 4, 5, and 6 on your own. So for number 4, you should have said you're going to use the tangent ratio. For number 5, you also said you were going to use the tangent ratio. And number 6, you're going to use the sine ratio. Okay? So the whole point of doing this is to be able to set up an equation and solve. So now comes the exciting part. How do I solve these types of problems? I have 3 steps. Step 1, determine which trig function to use based on the given information. Step 2, set up equation. So step 1, determine which trig function to use based on the given information. That's what I did on 1 through 6. I said, okay, I'm given opposite and hypotenuse, I'm using sine. So then on 1, 2, and 3, I showed you how to set up the equation. I would do sine of theta equals blank over blank. Okay? In step 3, I'm going to solve for x using the calculator. Okay. Your calculator evaluates sine, cosine, and tangent. I unfortunately can't show you how to use it on this, but I can show you how to use the calculator on a software which is called Desmos. Okay. So pause this video, finish writing this down because I'm going to start erasing it because I have 2 huge things I have to mention. Okay. So let me erase these here first. Alright, so huge thing number 1. Angle is always attached to the trig function. The angle is always attached to the trig function. Keep that in mind. It's huge. And then the last thing, which is absolutely crucial if you want the right answer, okay? Your calculator must be in degree mode. In your calculator, you have to put it in the degree mode. If you don't put it in the degree mode, the answers are going to be different, okay? In in trigonometry, there's there's 2 different modes in which your answers can be in, okay? And what that means, if I give you 1/2, you can put it in a fraction form, or you can give me a decimal form by 0.5. This is one mode. This is essentially another mode, okay? And then same thing if square roots. If I give you the square root of 2, and I turn that into a decimal, you get 1 point something, okay? This is a mode, this is a mode. This is in simplest radical form, this is in approximation form, okay? With trigonometry, we have 2 different modes. Those 2 modes are called radians and they're called degrees. You in geometry can only use the degree mode, which is the decimal mode. We're not good yet We're not experts yet to be able to use the radian mode, which is what you will use in trigonometry. Okay? How you put it in the degree mode. On your calculator, you press the mode button. It's right next to the second button all the way at the top. And then third way down, about three lines down, you see where it says radians and mode. You want to make sure the black highlighter is over, the black highlighting mark is over the word degree, and you hit enter. Okay? This has to happen every single time if you want the correct answer. Okay? So let's actually start solving some of these problems. So notice number one, it's a right triangle. So you have three options. You could do the Pythagorean theorem, you could do special right triangles, or you could use trig. Okay? Let's talk about this. Can I use the Pythagorean theorem on this problem? No. Why? Because I don't have two sides, I only have one side. Alright? How about special right triangles? No, because it's not a special right triangle. It's a 40, 90, and then 50 triangle. That's not special right triangles. So I have to use trig. So I'm going to highlight the angle that I'm given, which is 40 degrees. I'm going to use a prettier color than black. Okay? And from 40 degrees as my reference angle, I'm going to label O, A, and H. And I'm even going to write SOHCAHTOA up here to help me if I need it. Alright, so I have something for O and something for H. So what trig function uses something for O and something for H? Sine. So I'm going to set up my equation. So sine of my reference angle, which is 40, equals opposite, which is 12, over hypotenuse, which is x. Okay? So notice I have this thing that says sine of 40. Okay? Pretend this is like one giant variable. They are stuck together like glue. You cannot break up sine from 40. These two pieces are married together. They're like one giant variable x. Okay? So my goal is to get x by itself. My goal. So, how do I get x by itself? I got to get rid of fractions. How am I going to get rid of fractions? I'm going to multiply by x on both sides. So I have x sine of 40 equals 12. Is x by itself yet? No. Well, x is connected with sine of 40. So remember I said sine of 40 is like one giant variable. So how is sine of 40 and x connected? By multiplication. What's the inverse of multiplication? Division. So I'm going to divide by sine of 40. Divide by sine of 40. Okay? So in my calculator, I'm going to type 12 divided by sine of 40. If you don't have a calculator at home, you can Google the word Desmos.com. I'm pretty sure it'll work. Let's see. Yep, Desmos.com. Click Start Graphing. You have a graph over here. Just ignore this. Okay, this is where you want to type it in. If you see where it says functions, if I know how to use this, it should be working. I don't know why it's not. Oh, there we go. Functions. Notice I have sine, cosine, and tangent all right there. Okay? But in order to use these, I have to make sure it's in degree mode first. I'm going to hit this Allen wrench up here, and I'm going to put it in the degree mode first, and then I'm going to come back over here, and now I'm going to type 12 divided by sine of 40. And notice my answer, which is right here, which is 18.666. Okay? So let me see if I can figure out how to move this. Alright, so I'm moving it along. I'm just moving to the side over here. So, x equals 18.67. So let's do the next one. I can't do Pythagorean theorem because I don't have two sides. I can't do special right triangles because it's not a special right triangle, so I have to do trig. So highlight my reference angle, label O, A, H. Notice I am given a value for O, which is x, and a value for H, which is 16. So what trig function uses O and H? Well, that's sine. So now I'm going to set up my equation. Sine of my reference angle, 37, equals opposite over hypotenuse. Okay? So now notice this one. I have to get x by itself, so I'm going to multiply both sides by 16. So I have 16 sine of 37 equals x. So x is by itself, so all I have to do is type this into my calculator. So let's see if I can do this. And I think I messed up, but that's okay. I'll type in desmos.com again, just because I'm not great at using this program, and I'm trying the best that I can. And I'm going to put in degrees. I think it was 16 sine of 37. I get 9.6666. 9.6. I'm pretty sure it was 9.6. Of course, that's the wrong one. This one is 9.6. Yep. So x equals 9.6. Okay. So notice this problem over here was more steps to solve than this problem was over here. Why do you think that is? Because on this problem, x is on the denominator. Whenever x is in the denominator, it takes an extra step to get to x. When x is the numerator, it only takes one step to get to x. So keep that in mind. So let's try the next one. Highlight your reference angle. Label OAH. I have a side with O and a side with A, so I'm going to use tangent. So I'd say tangent of 36 equals opposite over adjacent. So now I got to get x by itself. So I'm going to multiply both sides by x. So I have x tan of 36 equals 12. I'm now going to divide by tan of 36. So now I'm going to open up another calculator. Got to go back to desmos.com because I don't know how to work this program the best, but that's okay. I'm doing pretty darn good if you ask me. So put it back in degrees. Except I forget what I'm supposed to type in. 12 divided by tan of 36. 12 divided by tan 36. I got 16.5. X equals 16.5. Okay. You also know if your answer is pretty logical, because notice this side is 12. So this side being 16 is about accurate. If this side was 12 and you solve for x and let's say you got 165, that's probably not a very logical answer. So just kind of as a heads up. All right. So go ahead and pause this video and try 5 and 6 on your own. So I now want everybody to go ahead and set up number 7. And I want to know why number 7 is a little funny. Why is number 7 funny? Label O-A-H. So I'm given A and H, so it'll be cosine of x equals 12 over 15. Why does this equation look funny? Because my angle is x. So I told you in the very beginning of this, there was no way I could break up cosine and x. My cosine and my angle, those were like that they were married and they were glued together. Okay? Fortunately in math, there's always a way to break somebody up. That's by doing the inverse. If I have 2x equals 12, you're going to divide by 2 on both sides because that's the inverse of multiplication. In math, we have the inverse. To get rid of cosine from x, I do the inverse of cosine, which is just called cosine of negative 1. What you do on one side, you have to do on the other side. Okay? Cosine of negative 1 is the inverse of cosine. So that would mean these would cancel out, and I'm left with x equals cosine of negative 1 equals 12 over 15. In your calculator, how I would get cosine of negative 1 is when I would press the blue button, which is second, and then I would hit cosine, because it says cosine of negative 1. Because I'm going to use Desmos, Let me show you. Put it in degrees. I would do, and I naturally forgot, what did that say? 12 over 15. All right. All right, so I would do functions. So notice here it says arc cosine, arc tangent, arc sine, but it says inverse up at the top. So I would do arc cosine, which is just cosine -1, 12 divided by 15. I get 36.8. So x equals 36.8 degrees. Because this is an angle, don't forget your degree sign. Okay? So if we look at number 8, I'm looking for theta. So OAH, I'm going to use cosine. If you don't like using theta, you can call that x. That's cool. So 12 over 13. So how am I going to get cosine and x broken up to get x alone? I want to do cosine of -1. So in my calculator, at least everything loads fast. I'm going to do arc cosine of, naturally I forgot, 12 divided by 13. 12 divided by 13. I get 22.6. So x equals 22.6 degrees. Okay? So go ahead and try the last 2 problems on your own. And come see me if you have any questions.